Tonight, before sleep begins to pull at the edges of your awareness, imagine stepping outside into the cool darkness of a quiet evening. The noise of the day has faded. The lights of distant houses glow softly behind you. Above, the sky stretches endlessly in every direction, filled with stars so numerous that counting them would be impossible. For a moment, let yourself forget the concerns of tomorrow. Forget the schedules, the obligations, the endless stream of information that fills modern life. Simply stand beneath the night sky and look upward. Because hidden within that vast darkness is one of the most unsettling mysteries humanity has ever encountered. The universe is unimaginably large. Our own Milky Way galaxy contains hundreds of billions of stars. Many of those stars possess planets. Some of those planets almost certainly resemble Earth. And beyond our galaxy lie trillions of other galaxies, each containing their own oceans of stars stretching into distances so vast that the human mind struggles to grasp them. If even a tiny fraction of those worlds developed life and even a tiny fraction of that life became intelligent, then the universe should be overflowing with civilizations. The mathematics suggests abundance. The evidence suggests silence. And between those two facts lies a question so profound that it has haunted scientists, philosophers, astronomers, and dreamers for generations. Where is everybody? The question sounds simple when spoken aloud, almost childlike in its directness. Yet beneath those three words hides a mystery that touches on our future, our significance, and perhaps even our survival. The story begins not beneath the stars, but during an ordinary lunch in the summer of 1950. At Los Alamos National Laboratory, physicist Enrico Fermi was sharing a meal with colleagues. The conversation drifted toward flying saucers and the possibility of extraterrestrial life. Fermi listened quietly, then he asked a question. "Where is everybody?" The room reportedly fell silent. Fermi was not dismissing the possibility of alien life, quite the opposite. He was pointing out something deeply strange. Given the age of the galaxy, the immense number of stars, and the enormous amount of time available for civilizations to develop, intelligent life should be common. Not merely possible. Common. The Milky Way is over 13 billion years old. Our Sun, by comparison, formed only about 4.5 billion years ago. Entire star systems existed billions of years before Earth was even born. If intelligent civilizations emerged around some of those ancient stars, they would possess an almost unimaginable head start over humanity. A civilization only 1 million years older than ours would appear godlike from our perspective. A civilization 100 million years older would be almost impossible for us to comprehend. And yet when we search the sky, we find nothing. No signals. No visitors. No vast engineering projects surrounding distant stars. No evidence that anyone has ever crossed the immense gulf between worlds. Only silence. A silence so profound that it has become one of the greatest puzzles in modern science. As you lie comfortably and listen, allow yourself to picture the scale involved. Imagine shrinking Earth until it becomes a grain of sand resting on a beach. At that scale, our Sun becomes a glowing sphere several meters away. The nearest star would be thousands of kilometers distant. The Milky Way itself would stretch across an entire continent. And yet even this analogy fails to capture reality. The distances involved are so vast that ordinary language begins to lose meaning. Light itself, the fastest thing known in the universe, travels nearly 300,000 kilometers every second. It circles Earth more than 7 times in a single heartbeat. Even moving at that incredible speed, light requires over 4 years to reach the nearest star beyond our Sun. To cross the Milky Way would require 100,000 years. To cross the observable universe would require billions. The cosmos is not merely large. It is staggeringly, overwhelmingly vast. And that vastness makes the silence even stranger. Because with so much space and so much time, intelligent life should have emerged again and again and again. Many scientists have attempted to estimate how many civilizations should exist. Even using extremely conservative assumptions, the numbers remain surprisingly large. Suppose only a small percentage of stars have planets. Suppose only a small percentage of those planets can support life. Suppose only a small percentage of those worlds actually develop living organisms. Suppose only a small percentage of those organisms evolve intelligence. And suppose only a small percentage of intelligent species build technology capable of communication. Even after multiplying all those unlikely conditions together, we still arrive at a galaxy that should contain numerous civilizations. Perhaps hundreds. Perhaps thousands. Perhaps far more. And yet the sky remains quiet. Imagine walking into a vast city containing billions of homes. Every window is dark. Every street is empty. Every building is silent. You know people should be there. Everything about the city suggests life. Yet no voices emerge. No footsteps echo. No lights appear. The emptiness itself becomes unsettling. That is what astronomers experience when they look into the universe. The silence becomes information. The absence becomes a clue. Something somewhere does not fit. For decades, scientists hoped that improved technology would solve the mystery. Radio telescopes grew larger. Detectors became more sensitive. Powerful observatories scanned the heavens. The search for extraterrestrial intelligence expanded year after year. Yet the result remained the same. Nothing. Not a single confirmed signal. Not a single undeniable sign of another technological civilization. The universe continues to offer beauty and abundance. But company remains elusive. And this is where the mystery begins to change from a scientific question into something far more personal. Because the answer may not simply tell us whether aliens exist. The answer may tell us something about humanity's future. Imagine a long path stretching from lifeless matter to a civilization capable of traveling among the stars. The path begins with chemistry. Then life emerges. Life becomes complex. Complex organisms evolve intelligence. Intelligence develops language. Language creates culture. Culture creates science. Science creates technology. Technology creates civilization. And civilization reaches toward the cosmos. Each step seems natural when viewed from the perspective of our own history. But what if one of those steps is incredibly difficult? What if somewhere along that path lies an obstacle so severe that almost nobody ever passes it? A barrier so deadly that entire civilizations disappear before reaching the stars. This idea would eventually become known as the Great Filter. But before we explore that possibility, we must first appreciate the astonishing improbability of our own existence. Because when we look back through Earth's history, we discover a chain of events so fragile and unlikely that it begins to feel almost miraculous. For billions of years, life remained simple. For billions of years, there were no civilizations. No telescopes. No cities. No art. No music. No questions about the universe. Only microscopic organisms drifting through ancient oceans beneath unfamiliar skies. The journey from those humble beginnings to the modern world took almost the entire history of our planet. And yet somehow, through countless extinctions, catastrophes, and near misses, one species eventually learned to ask questions about its place in the cosmos. One species learned to look upward. One species learned to wonder. Perhaps that species is ordinary. Perhaps it is extraordinarily rare. We do not yet know. What we do know is that the night sky appears strangely empty. And the deeper we look, the more mysterious that emptiness becomes. In the next chapter, we will travel deeper into the numbers behind the paradox itself, exploring why many scientists believe that somewhere between the birth of a planet and the rise of a galactic civilization, an invisible barrier may be waiting. A barrier that could already be behind us. Or one that may still lie ahead. For now, let the stars remain above you. Silent, ancient, patient. And as sleep slowly approaches, remember that every human who has ever lived has looked into that same darkness and wondered what might be waiting there. If you enjoyed this journey into the mysteries of the cosmos, please subscribe to Space Sleep Theory and join us for the next chapter, where we continue our exploration of the Great Filter and humanity's place in the silent universe. The strange thing about the Great Filter is that it begins not with fear, but with optimism. Before scientists became concerned about the silence of the cosmos, many assumed that intelligent life must be common. After all, once you truly grasp the scale of the universe, it becomes difficult to imagine otherwise. Tonight, as you settle deeper into comfort, allow your mind to drift outward beyond Earth, beyond the solar system, beyond even the familiar spiral arms of the Milky Way. Imagine yourself floating high above our galaxy, watching it slowly rotate beneath you like a luminous wheel of stars suspended in darkness. From this perspective, Earth disappears completely. Humanity vanishes. Every nation, every city, every memory, every story becomes invisible. What remains is a galaxy containing somewhere between 200 billion and 400 billion stars, each one a possible sun, each one a potential home for worlds we may never see. For most of human history, we had no idea how many stars existed. Ancient civilizations looked upward and saw thousands. Today we know that even on the clearest night, the stars visible to the naked eye represent only a tiny fraction of what is actually there. Our galaxy alone contains more stars than all the humans who have ever lived. And the Milky Way itself is merely one galaxy among approximately 2 trillion galaxies scattered throughout the observable universe. The numbers become so large that they almost cease to function. The human brain evolved to understand dozens, perhaps hundreds, maybe thousands. It did not evolve to intuitively comprehend trillions. Yet the universe operates comfortably at scales that dwarf our imagination. If every grain of sand on every beach and desert on Earth represented a star, there would still be more stars in the observable universe than grains of sand beneath all human feet combined. When astronomers began discovering planets around other stars in the 1990s, a profound shift occurred. Before then, some wondered whether our solar system might be unique. Perhaps planets themselves were rare. Perhaps Earth occupied an unusual corner of reality, but the evidence told a different story. Planet after planet appeared, then hundreds, then thousands. Today, the data suggests that planets are not unusual at all. They seem to be one of the most common products of star formation. Wherever stars are born, planets often follow: rocky worlds, gas giants, frozen wastelands, ocean-covered spheres, entire families of planets orbiting suns that rise and set over alien horizons. The universe appears remarkably efficient at creating worlds. And among those countless worlds, many reside within what scientists call the habitable zone. This is the region around a star where temperatures may allow liquid water to exist on a planet's surface. Water, as far as we know, is one of the fundamental ingredients for life. Not because life must use water everywhere, but because every living thing we have ever observed depends upon it. The search for habitable worlds is therefore, in some sense, a search for places where the story of Earth might have repeated itself. Current estimates suggest there may be tens of billions of potentially habitable planets in the Milky Way alone. Tens of billions. Even if most remain barren, the sheer quantity seems overwhelming. This realization creates a strange tension. The more planets we discover, the more mysterious the silence becomes. Imagine entering a vast forest and finding not one cabin but millions. Every cabin contains a fireplace, a source of water, fertile soil nearby, and everything necessary for life. Yet not a single light shines through any window. Not a single voice emerges from within. At first, the emptiness might seem normal, but eventually the absence itself demands explanation. The universe increasingly resembles such a forest. Everywhere we look, we find potential homes, yet we do not find neighbors. To understand why this is so unsettling, scientists often turn to an idea known as the Drake equation. Created in 1961 by astronomer Frank Drake, the equation was never intended to provide a precise answer. Instead, it served as a framework for thinking about the problem. How many civilizations should exist in our galaxy right now? The equation breaks the question into a series of smaller questions. How many stars form each year? How many possess planets? How many planets could support life? How often does life emerge? How often does intelligence evolve? How often does intelligence develop technology? And how long do technological civilizations survive? At first glance, the equation seems straightforward, but hidden within those variables are some of the deepest mysteries in science. We know a great deal about stars. We know a great deal about planets. Yet when we reach questions involving life and intelligence, certainty begins to dissolve. We possess only one example: Earth, one biosphere, one evolutionary history, one technological civilization. Imagine trying to understand the nature of forests after seeing only a single tree. That is our current position. Nevertheless, even conservative assumptions often produce surprising results. Suppose life emerges on only 1% of habitable worlds. Suppose intelligence evolves on only 1% of living planets. Suppose technological civilizations arise on only 1% of intelligent worlds. The numbers remain substantial. Thousands of civilizations should still exist across the galaxy. Not millions, not billion, just enough that we should expect evidence somewhere. A signal, a probe. A structure, something. Instead, we encounter what scientists call the Great Silence. The silence becomes even stranger when time enters the equation. Human civilization feels ancient to us. Recorded history stretches back several thousand years. Entire empires have risen and fallen, religions have emerged, languages have evolved, yet compared to the age of the galaxy, human civilization is younger than a newborn infant. The Milky Way has existed for over 13 billion years. Humanity has possessed radio technology for roughly a century. If the galaxy were compressed into a single calendar year, human technological civilization would occupy only the final seconds before midnight on December 31st. Now imagine another civilization emerging just 1 million years before us. 1 million years sounds immense from a human perspective, yet on cosmic scales it is almost nothing. A civilization with a 1 million year head start could potentially spread across enormous regions of the galaxy. If it survived, if it remained interested in exploration, if it avoided destruction. The galaxy has provided billions of years for such opportunities. Not 1 million, not 10 million, billions. This is where the paradox sharpens into something genuinely unsettling. The problem is not merely that alien civilizations should exist. The problem is that even a single successful civilization might eventually become visible across enormous distances. Imagine a species developing the ability to travel between stars. They establish a colony around a nearby sun. That colony grows and launches its own missions. Those new settlements repeat the process. Expansion continues slowly but steadily. Even moving at modest speeds, such a civilization could spread across the Milky Way in a surprisingly short period of cosmic time. Perhaps a few million years, perhaps tens of millions. Regardless of the exact figure, it remains tiny compared to the age of the galaxy itself. And yet we see no sign that this has happened. No galactic empires. No vast engineering projects. No unmistakable signatures of advanced intelligence. Nothing. The realization leads toward a troubling conclusion. Somewhere between lifeless matter and galaxy-spanning civilization, something goes wrong. Something prevents nearly everyone from completing the journey. The path exists. We know it exists because we ourselves have begun walking it, yet the path appears strangely empty. Imagine climbing a mountain and discovering countless abandoned camps along the trail. Equipment scattered, fires long extinguished, no climbers visible above, no footprints continuing toward the summit. Eventually you would begin to suspect that something dangerous lies ahead, something that stops nearly everyone who attempts the ascent. The great filter is in many ways exactly that suspicion projected onto the universe itself. Perhaps the filter lies behind us. Perhaps one of the steps already completed by life on Earth is extraordinarily improbable. If so, humanity may be among the rare survivors of a cosmic lottery whose odds defy comprehension. That possibility is comforting. It means the hardest part may already be over. But there is another possibility. Perhaps the filter lies ahead. Perhaps civilizations routinely reach our current level of development. They discover nuclear energy. They create artificial intelligence. They manipulate biology. They unlock tremendous power. And then, somewhere shortly afterward, they disappear. The night sky offers no answer. Only silence. And silence in this context is not empty, it is heavy with implications. As you continue drifting toward sleep, imagine standing once more beneath the stars. Above you stretches a universe so vast that its true scale cannot be fully understood. Somewhere within that immensity lies the answer to Fermi's question. Somewhere hidden among trillions of stars is the reason the cosmos remains quiet. In the next chapter, we will begin exploring the possible locations of the Great Filter itself, examining the extraordinary events in Earth's history that may have been far rarer than we ever imagined, and asking whether humanity has already passed the most dangerous barrier, or whether we are unknowingly approaching it now. Until then, let the mystery linger. Let the stars remain silent, and let the question drift with you into the darkness. Where is everybody? If the universe is truly filled with planets, and if the laws of physics operate the same way everywhere, then perhaps the most important question is not where intelligent civilizations are. Perhaps the more fundamental question is how any civilization begins at all. Tonight, as your thoughts slow and your breathing settles into a gentle rhythm, imagine traveling backward through time. Not years, not centuries, not even millions of years. Imagine drifting backward across billions of years until Earth itself becomes almost unrecognizable. The continents disappear, forests vanish, animals fade away, the oceans remain, but they belong to a different world. A younger world, a silent world, a planet without cities, without language, without thought. A planet where life, as far as we know, has not yet appeared. For all our technological achievements, for all our understanding of physics and chemistry, there's one event we still cannot fully explain: the origin of life itself. We know life exists because we are here. We know it appeared on Earth remarkably early in our planet's history. Yet the precise moment when non-living matter crossed the threshold into something alive remains hidden behind a veil of mystery. And the deeper scientists investigate that mystery, the more astonishing it appears. Imagine an ocean stretching beneath an alien sky more than 3.5 billion years ago. No fish swim beneath the waves, no birds cross the horizon, no trees line distant shores. The Earth is quiet in a way that is difficult for modern humans to imagine. The only sounds would be wind, water, volcanic eruptions, and the slow geological movements of a young planet still settling into its shape. Somewhere within this environment, chemistry begins to perform a remarkable trick. Atoms combine into molecules. Molecules form larger structures. Complex chemicals emerge. And eventually, somehow, something extraordinary happens. Matter begins to copy itself. This may sound simple, but it represents one of the most profound transformations in the history of the universe. Everything alive today, every tree, every whale, every human being traces its ancestry back to that transition. Somewhere, sometime, a collection of molecules acquired the ability to reproduce. It could make copies, imperfect copies, copies that could change. And once that process began, evolution could take over. The entire history of life follows from that single event. Yet despite decades of research, scientists still do not know exactly how it happened. Laboratories around the world have recreated conditions that may have existed on early Earth. Researchers have shown that amino acids, the building blocks of proteins, can emerge naturally under certain circumstances. Organic molecules form surprisingly easily. The ingredients of life seem willing to appear wherever chemistry is given an opportunity, but ingredients are not the same as life itself. A pile of bricks is not a cathedral. A collection of letters is not a novel. And a soup of organic molecules is not a living cell. Between chemistry and biology lies a gap that remains one of science's greatest mysteries. This uncertainty creates an intriguing possibility. What if the origin of life is extraordinarily difficult? What if the first living system requires such a specific combination of conditions that it almost never happens? If that is true, then the great filter may already be behind us. Life itself would be the miracle. The universe could contain countless habitable planets, oceans, atmospheres, and favorable climates, yet remain almost entirely lifeless because the leap from chemistry to biology is simply too improbable. Imagine buying a lottery ticket with odds so extreme that winning is effectively impossible. Now imagine every habitable planet in the universe holding such a ticket. Most lose, almost all lose, but somewhere once in a great while one wins. Perhaps Earth is one of those winners. At first, this idea feels unlikely. After all, life appeared relatively quickly on our planet. Earth formed approximately 4.5 billion years ago, and evidence suggests life may have emerged within the first billion years. To some scientists, this suggests that life arises easily whenever conditions allow. But there is another interpretation. We can only observe planets where life succeeded. If life had never emerged here, there would be no observers around to notice its absence. Our perspective may be biased without us realizing it. This concept, known as anthropic reasoning, can feel strange at first, yet it is deeply important when discussing the Great Filter. Imagine millions of planets scattered across the galaxy. On most of them, life never begins. They remain silent forever. On one world, however, life appears. Billions of years later, intelligent observers emerge and begin asking questions about the universe. Naturally, those observers find themselves on a planet where life succeeded. They could never have found themselves anywhere else. In other words, the fact that life appeared on Earth does not necessarily mean life is common. It simply means we inhabit one of the places where it happened. The distinction is subtle but profound. As scientists explored the history of life, another mystery emerged. Even after life appeared, progress toward complexity was astonishingly slow. For nearly 2 billion years, Earth remained dominated by simple microscopic organisms. Life existed certainly, but it showed little sign of becoming more elaborate. Entire oceans were populated by tiny single-celled creatures. Generation followed generation. Millions of years passed, then hundreds of millions, then billions. Nothing resembling animals appeared. Nothing resembling intelligence emerged. Life seemed content to remain simple. This long period of biological stability suggests another possible filter. Perhaps the appearance of life is not the difficult step, perhaps complexity is. Roughly 2 billion years ago, something remarkable occurred. One simple cell engulfed another. Instead of digesting it, the two formed a partnership. The smaller cell became what we now know as the mitochondrion, the tiny energy-producing structure found within almost every complex cell on Earth. This event may sound technical, but its consequences were extraordinary. It allowed cells to access vastly greater amounts of energy, and with more energy came new possibilities. Complex life became possible. Every plant, every animal, every fungus, every human being ultimately descends from that ancient merger. And here is the strange part. As far as scientists can tell, it happened only once. Despite billions of years and countless opportunities, this transformative event appears to have occurred a single time. Every complex organism alive today belongs to the lineage that resulted from that one successful partnership. Had it never happened, Earth might still be populated exclusively by microbes. Think about that for a moment. For billions of years, life existed without producing anything remotely resembling intelligence. No civilizations. No telescopes. No music. No dreams. Only microscopic organisms drifting through ancient seas. If that transition from simple cells to complex cells is extraordinarily rare, then it may represent another component of the Great Filter. Life might emerge on many worlds yet remain trapped forever in a microbial state. And even after complexity appeared, the waiting continued. Another billion years passed before multicellular organisms became common. Another vast stretch of time during which the universe remained silent. The timeline of Earth begins to look less like an inevitable march toward intelligence and more like a sequence of unlikely breakthroughs separated by enormous periods of waiting. One miracle. Then another. Then another. Each step requiring conditions we do not fully understand. Imagine standing before a series of locked doors stretching into darkness. Behind the final door lies civilization. Behind another lies intelligence. Behind another, complex life. Behind another, the origin of life itself. To reach our current position, Earth had to unlock every single door. Missing even one would have left the planet silent and empty of observers. This realization changes how we view our existence. We often think of humanity as the natural outcome of evolution, yet the fossil record tells a more fragile story. Again and again, history could have unfolded differently. Asteroids struck, continents shifted, species vanished, entire ecosystems collapsed. Countless evolutionary paths ended in extinction. The overwhelming majority of organisms that have ever lived are gone. Gone so completely that no trace remains. And yet somehow, through an almost unimaginable sequence of contingencies, one lineage survived. One lineage learned to use tools. One lineage developed language. One lineage looked upward and began asking questions. The philosopher Nick Bostrom once suggested that if the Great Filter lies behind us, then humanity may be extraordinarily special. Not special in the sense of destiny or superiority, but special in the statistical sense. We may be the survivors of an almost impossible chain of events, a cosmic lottery winner standing atop billions of years of accumulated improbability. That possibility offers comfort. Because if the most difficult steps are already behind us, then perhaps our future remains open. Perhaps the silence of the universe exists because almost nobody ever makes it this far. But there is another possibility. What if life is common? What if simple organisms emerge easily wherever conditions permit? What if microbial life fills the cosmos? If that is true, then the Great Filter cannot be located at the origin of life. It must lie further ahead, somewhere closer to intelligence, somewhere closer to civilization. Somewhere closer to us. And that possibility carries a very different emotional weight. Because every filter behind us is reassuring. Every filter ahead of us is terrifying. As you drift deeper into relaxation, imagine Earth during those ancient ages before animals existed. A blue world beneath an unfamiliar sky. Oceans stretching endlessly across the horizon. Life present yet invisible to the naked eye. For billions of years, the planet waited. Not because it knew what was coming, not because evolution had a destination, but because complexity, intelligence, and civilization required a chain of events so unlikely that they unfolded only once. Or so it seems. In the next chapter, we will continue following that chain forward through time, exploring the emergence of intelligence itself and asking one of the most uncomfortable questions in all of science. Was humanity inevitable? Or are we the result of an accident so improbable that it may never happen again anywhere in the universe? For now, let the ancient oceans remain calm in your imagination. Let the young Earth drift silently through space beneath distant stars. And remember that before there were cities, before there were civilizations, before there were thoughts, there was only a fragile spark of life struggling to survive in a vast and indifferent cosmos. A spark that somehow endured. A spark that eventually became us. If life itself was the first miracle, then intelligence may have been the second. As you settle deeper into the comfort of the night, imagine once again traveling through Earth's immense history. The ancient oceans have already produced life. Complex cells have emerged. Multicellular organisms now populate the seas. Time continues its slow march forward. Millions of years pass like drifting clouds. Continents shift, mountains rise and erode away. Entire species appear and vanish without leaving descendants. Evolution experiments endlessly, generating forms so strange that if we saw them today, we might mistake them for creatures from dreams. And yet throughout all this time, something remarkable is missing. Nobody is thinking about the universe. Nobody is building civilizations. Nobody is asking questions. Life flourishes, but awareness remains limited to immediate survival. Eat, reproduce, avoid danger, continue existing. For hundreds of millions of years, this is enough. It is tempting to assume that intelligence is the natural destination of evolution. After all, intelligence produced technology, and technology allowed one species to dominate an entire planet. Looking backward from our current position, it is easy to imagine that evolution was always moving toward minds like ours. But the fossil record tells a very different story. It suggests that intelligence may not be an inevitable outcome at all. It may be one of the strangest accidents in the history of life. Imagine pressing rewind on the history of Earth. The dinosaurs return. The mammals disappear. The continents rearrange themselves. The great forests recede. The oceans chain. Now press play again. Would humanity reappear? Many evolutionary biologists suspect the answer is no. Not because evolution would fail, life would continue, new species would emerge, ecosystems would develop, predators would hunt prey, countless organisms would adapt to their environments, but the exact chain of events that produced human intelligence might never happen again. Evolution has no goal. It does not plan. It does not look ahead. Natural selection favors traits that improve survival and reproduction in the present moment. Intelligence is only one possible strategy among many. Strength works, speed works, camouflage works, venom works, flight works. Millions of species have survived perfectly well without developing mathematics, philosophy, or radio telescopes. For most of Earth's history, intelligence offered little advantage compared to simpler solutions. A shark does not need calculus. An eagle does not need astronomy. A tiger does not need particle physics. They survive quite successfully without them. This observation leads to a fascinating question. If intelligence is so useful, why did it appear only once? Throughout Earth's history, millions upon millions of species have lived and died. Countless evolutionary experiments unfolded across billions of years, yet only one lineage developed language sophisticated enough to create civilizations. Only one lineage built machines. Only one lineage learned to split the atom and contemplate distant galaxies. That fact should feel stranger than it often does. Because intelligence seems obvious to us. We are intelligent. We view the world through the lens of thought and self-awareness. But intelligence may actually be extraordinarily rare. Imagine walking through a vast forest containing millions of trees. Every tree grows differently. Every tree adapts to its surroundings. Yet among all those millions, only one produces a flower. That flower might begin to seem less like an inevitable result and more like a statistical anomaly. Some scientists believe intelligence may represent exactly that kind of anomaly. Consider the dinosaurs. They dominated Earth for approximately 160 million years. Humans have existed in our current form for roughly 300,000 years. The dinosaurs ruled the planet for a period more than 500 times longer than our entire species has existed. And yet none developed advanced technology. None built civilizations. None constructed telescopes. They were extraordinarily successful by evolutionary standards. They occupied nearly every environment on Earth. They thrived for immense stretches of time. If intelligence were an inevitable outcome of evolution, one might expect it to have emerged somewhere among them. It did not. Then came the asteroid. 66 million years ago, a mountain-sized object slammed into Earth with unimaginable force. The impact released more energy than billions of nuclear weapons detonating simultaneously. Forests burned, oceans surged, dust filled the atmosphere, entire ecosystems collapsed. And the dinosaurs disappeared. At first glance, this seems like a tragedy. But from another perspective, it may have been one of the most consequential events in the history of intelligence. Had that asteroid missed Earth entirely, mammals might never have inherited the planet. Human beings might never have existed. Every book ever written, every song ever composed, every scientific discovery, every dream, every memory, all absent. A slight alteration in the trajectory of a distant rock may have determined whether conscious beings would ever gaze at the stars from Earth. The implications are difficult to fully absorb. Our existence may depend upon a chain of accidents extending back hundreds of millions of years. And the asteroid is only one example. Again and again, history appears balanced on a knife edge. A species survives when extinction seems likely. A mutation occurs at exactly the right moment. A climate shift creates new opportunities. A catastrophe removes dominant competitors. The further we look into our evolutionary past, the more fragile the entire process appears. Stephen Jay Gould, one of the most influential evolutionary thinkers of the 20th century, proposed a famous thought experiment. Imagine rewinding the tape of life and allowing evolution to unfold again from the same starting point. Would humans appear? Gould believed the answer was probably not. The details of history matter. Small changes accumulate. Different accidents occur. Different species survive. Different possibilities emerge. The result could be a world filled with life but lacking anything resembling human intelligence. This idea is deeply relevant to the Great Filter. Because if intelligence itself is extraordinarily improbable, then perhaps we have already passed another major barrier. Perhaps the universe contains countless planets covered in life. Perhaps oceans teem with alien microorganisms. Perhaps forests grow beneath distant suns. Yet perhaps none of those worlds ever produce minds capable of building civilizations. Life alone is not enough. Complex life alone is not enough. Even large brains may not be enough. Something more is required. And whatever that something is, Earth appears to have achieved it only once. There is another detail that often goes unnoticed. Human intelligence emerged astonishingly recently. If Earth's history were compressed into a single day, modern humans would appear during the final seconds before midnight, not the final hour, not the final minute. The final seconds. For more than 4 billion years, Earth existed without human civilization. 4 billion years of oceans, storms, mountains, volcanoes, bacteria, plants, insects, reptiles, and mammals. 4 billion years of life without telescopes. Then suddenly, almost instantaneously on geological timescales, intelligence appeared. It is as though the universe spent an entire day preparing a stage, only for the main performance to begin moments before the curtains closed. Why did it take so long? Scientists do not fully know. Perhaps intelligence requires extraordinary conditions. Perhaps it emerges only after countless evolutionary dead ends. Perhaps Earth was simply lucky. Whatever the answer, one fact remains difficult to ignore. The path from simple life to intelligent civilization consumed almost the entire available history of our planet. This observation troubled some researchers. If intelligence requires billions of years to emerge, then many worlds may never have enough time. Stars age, planets change, catastrophes occur, environmental conditions shift. The window of opportunity may close before intelligence has a chance to appear. In this view, the universe may be filled with planets perpetually stuck at earlier stages. Worlds covered with microbial oceans. Worlds populated by simple organisms. Worlds where evolution never quite reaches self-awareness. Entire biospheres that remain forever silent. Imagine walking through an enormous library containing billions of books. Most are blank. Some contain a few words. A smaller number contain simple stories. And only one contains a reader capable of understanding what is writ. That reader is humanity. At least as far as we currently know. The realization can feel lonely. Yet it can also feel strangely beautiful. Because if intelligence is rare, then consciousness itself becomes precious. Every thought, every dream, every act of curiosity, every moment of wonder. These may be among the rarest phenomena in the universe. The stars shine regardless of whether anyone observes them. Galaxies spin whether anyone notices or not. Black holes consume matter in silence. But awareness changes everything. For the first time, the universe becomes capable of reflecting upon itself. Atoms organize into minds. Minds contemplate atoms. The cosmos becomes both observer and observed. And somehow, against staggering odds, that process happened here. Or at least it happened once. Yet there remains an unsettling possibility. What if intelligence is not the final difficult step? What if reaching our current level is relatively easy compared to what comes next? After all, intelligence gave humanity tremendous power. But power creates new dangers. The ability to reshape the world is also the ability to destroy it. And perhaps that is where the real filter waits. Not in the emergence of intelligence, but in what intelligence eventually does with itself. As your thoughts grow heavier and sleep draws nearer, imagine standing once more beneath the night sky. Around distant stars, life may have appeared countless times. Somewhere, complex organisms may have evolved. Somewhere, alien creatures may hunt, swim, crawl, or fly beneath unfamiliar suns. But intelligence, civilization, technology, those may be far rarer. And if that is true, then humanity occupies an extraordinarily unusual position in cosmic history. We may have already crossed barriers that almost no one else ever survives. Or we may simply be approaching the most dangerous barrier of all. In the next chapter, we will explore the darker possibility. The possibility that civilizations routinely reach our level of technological power only to vanish shortly afterward. The possibility that the great filter is not hidden in the distant past but waiting somewhere in our future. For now, let the stars remain above you. Silent, ancient, watching, and let yourself drift peacefully into the mystery of how a universe made of dust and fire somehow learned to think. There is a certain comfort in believing that the hardest part is behind us. If the great filter exists somewhere in the distant past, within the origin of life, the emergence of complex cells, or the unlikely rise of intelligence, then humanity may already be among the rare survivors of a cosmic obstacle course. The silence of the universe would become reassuring rather than frightening. We would look up at the stars and conclude that intelligent life is rare because the necessary sequence of miracles almost never occurs. We would be lucky, extraordinary, statistically improbable, and perhaps safe. But tonight, as we continue our journey through one of the deepest mysteries in science, we must confront another possibility. A possibility that many researchers find far more unsettling. What if the great filter is not behind us? What if it is ahead? Imagine for a moment that life emerges easily throughout the cosmos. Imagine that biology is not a miracle but a natural consequence of chemistry. Give a planet liquid water, stable conditions, and enough time, and life appears. Perhaps microbial organisms are common. Perhaps complex ecosystems develop on countless worlds. Perhaps intelligence itself evolves more frequently than we assume. In such a universe, civilizations would arise again and again across billions of years. And yet we still observe silence. No signals. No visitors. No ancient galactic empires stretching across the stars. Only darkness. If civilizations are common, then something must be happening to them. Something prevents them from reaching the future. Something stops them before they become visible across cosmic distances. The implication is difficult to escape. Civilizations may be destroying themselves. As you listen, imagine a distant planet orbiting a star much like our sun. For billions of years, life evolves. Eventually, an intelligent species emerges. They develop language, agriculture, science, technology. Their history may differ from ours in countless ways, yet certain patterns begin to appear. Knowledge accumulates, energy consumption increases, their understanding of nature deepens. They learn to harness the forces hidden within matter itself. For a time, progress feels unstoppable. Then something changes. Perhaps they invent weapons more powerful than their wisdom. Perhaps their technology advances faster than their ability to manage its consequences. Perhaps the very intelligence that elevated them becomes the source of their downfall. The stars remain silent because the story ends there. This possibility is not science fiction. It emerges naturally from the realities of technological civilization. Humanity itself provides the first example. Consider how recently our species acquired the ability to destroy itself. For hundreds of thousands of years, humans existed with relatively limited power. We hunted, we farmed, we built communities. Wars occurred certainly, but the scale of destruction remained constrained by technology. Then, in the span of a few generations, everything changed. The Industrial Revolution unlocked vast reserves of energy, scientific knowledge accelerated, machines transformed society, electricity illuminated cities, aircraft conquered the skies, radio carried information across continents. And then humanity split the atom. In August of 1945, the world entered a new era. For the first time in Earth's history, a single species possessed the ability to cause global catastrophe through its own actions. The bombs dropped on Hiroshima and Nagasaki demonstrated a terrifying reality. Intelligence had created power on a scale evolution had never encountered before. The significance of this moment extends beyond human history. It may represent a universal threshold. Any civilization sufficiently advanced to understand physics may eventually discover nuclear energy. The same scientific principles that enable clean power generation also permit the construction of devastating weapons. Knowledge itself becomes double-edged. Every technological breakthrough carries both promise and danger. This pattern repeats throughout history. The mastery of fire provided warmth and protection. It also allowed destruction. Industrial chemistry produced medicine and agriculture. It also created toxins and weapons. Biotechnology offers the potential to cure disease. It may also introduce unprecedented risks. Artificial intelligence promises extraordinary capabilities. Yet its long-term consequences remain uncertain. Progress solves problems. Progress creates new problems. And each generation inherits challenges more powerful than those faced by the last. Imagine a civilization climbing a mountain. With every step upward, the view improves, new possibilities appear, greater knowledge becomes available, but the higher they climb, the steeper the cliffs become. Mistakes that were once survivable now carry catastrophic consequences. Perhaps this is the true great filter. Not a single obstacle, not one dramatic event, but a sequence of escalating challenges. Each technological advancement grants greater power while simultaneously increasing the stakes of failure. Eventually, a civilization reaches a point where wisdom must grow as quickly as capability. If it cannot, the climb ends. What makes this possibility so unsettling is that humanity may already be approaching such a threshold. Never before have we possessed so much power over our environment. We can alter ecosystems, modify genetic code, influence the global climate, create machines capable of performing increasingly sophisticated tasks. For the first time, a single species has become a planetary force. From one perspective, this achievement is extraordinary. From another, it is deeply precarious. The philosopher Bertrand Russell once observed that humanity's problem is not a lack of intelligence but a mismatch between intelligence and wisdom. Our ability to achieve goals often exceeds our ability to choose them wisely. Technology amplifies intentions. It does not necessarily improve judgment. The universe may be filled with civilizations that encountered the same challenge. Imagine a species slightly older than humanity. They discover advanced energy systems centuries before we do, their cities flourish, their science progresses, their future appears bright. Then political conflict emerges, or environmental collapse, or runaway technological competition, or an invention whose consequences cannot be contained. The details may vary, but the outcome remains the same. The civilization never reaches the stars. Its history ends on its homeworld. Its signals fade into silence. And somewhere, millions of years later, another young civilization looks upward and wonders why the galaxy seems empty. This possibility introduces a chilling reinterpretation of the night sky. The silence may not indicate absence. It may indicate failure. The stars may not be empty because life is rare. They may be empty because survival is difficult. Imagine walking through an ancient forest and noticing countless tree stumps. No living giants remain, only traces of what once stood there. You begin to suspect that something repeatedly prevents trees from reaching maturity. The absence becomes evidence. The silent galaxy may be telling a similar story. A story written not in words but in missing civilizations. Of course, we must be careful. The great filter remains a hypothesis, not a proven fact. There are many possible explanations for the Fermi Paradox. Advanced civilizations may choose not to communicate. Interstellar travel may be far more difficult than we imagine. Alien societies may exist in forms we fail to recognize. The universe may still be teeming with intelligence hidden beyond our current ability to detect. Yet the possibility of a future filter remains difficult to ignore. Because we know one thing with certainty. Humanity has not yet demonstrated that technological civilization can survive indefinitely. We simply have not existed long enough. Our species has mastered radio communication for little more than a century. We have possessed nuclear weapons for less than that. In cosmic terms, these are not even moments, they are fractions of moments. Imagine meeting a teenager who has just learned to drive and immediately declaring them a perfect driver for the rest of eternity. Such confidence would be absurd. Experience matters, time matters, long-term survival must be demonstrated, not assumed. Human civilization is still very young. Perhaps astonishingly young. We may be living through the most dangerous period in our entire future without fully realizing it. Or perhaps we are witnessing the birth of something extraordinary. The first steps toward a civilization capable of surviving for millions of years. The truth is that we do not know. And that uncertainty lies at the heart of the great filter. As you relax further into the quiet rhythm of the night, consider the generations who came before us. Ancient humans gazed at the same stars without knowing what stars truly were. They could not imagine galaxies, black holes, exoplanets, or the immense age of the cosmos. Yet they looked upward with the same curiosity that lives within us today. Now the responsibility has become ours. We are the first generation capable of recognizing the possibility of a great filter. The first generation capable of understanding that humanity's future may carry significance beyond our own planet. Because if civilizations repeatedly vanish, then every successful civilization becomes precious. Every world that survives becomes a victory against cosmic silence. And perhaps that is the deepest lesson hidden within the Fermi Paradox. The future is not guaranteed. The continuation of intelligence is not inevitable. The story can end, but it does not have to. In the next chapter, we will explore some of the most surprising possibilities proposed by scientists and philosophers, including the idea that advanced civilizations may deliberately remain invisible, hiding from one another in a cosmic wilderness far stranger than we have imagined. For now, let the stars hang quietly above you, let the darkness feel vast but peaceful. And remember that somewhere between the birth of intelligence and the conquest of the stars lies a test that every civilization must face. The question is not whether the test exists. The question is whether anyone passes it. And whether we will. There is another possibility. A possibility stranger than extinction. Stranger than cosmic disasters. Stranger, perhaps, than the idea that civilizations routinely destroy themselves. What if the universe is not silent because nobody is there? What if the universe is silent because everybody is listening? As you settle deeper into the darkness of the night, imagine standing alone in an enormous forest long after sunset. The trees stretch endlessly in every direction. No moonlight reaches the ground. Every shadow conceals unknown possibilities. Somewhere beyond your vision, other travelers may be moving through the same forest. You cannot see them, they cannot see you. The darkness hides everyone equally. Now imagine that survival depends on remaining unnoticed. Imagine that revealing your location carries unimaginable risk. How loudly would you speak? Would you call out into the darkness? Or would you remain silent? This idea forms the foundation of one of the most unsettling solutions ever proposed for the Fermi Paradox. Known as the dark forest hypothesis, it suggests that advanced civilizations may intentionally conceal their existence, not because they are antisocial, not because they lack curiosity, but because the universe may be a place where caution is the only reliable path to survival. The concept begins with a simple observation. When dealing with alien civilizations, uncertainty becomes almost absolute. On Earth, even among strangers, we share certain assumptions. Human beings possess common biology, common evolutionary pressures, common needs and limitations. We understand at least roughly what motivates one another. Misunderstandings occur, certainly, but beneath them lies a foundation of shared experience. An alien civilization would be different. Potentially unimaginably different. Their psychology could be unlike anything humanity has ever encountered. Their values could be incomprehensible. Their goals could have no equivalent in human thought. They may not hate us. They may not love us. They may not even categorize reality in ways we would recognize. And because of that uncertainty, predicting their behavior becomes nearly impossible. Imagine encountering another civilization across interstellar distances. You detect their signals, you confirm their existence. Now what? Can you trust them? How would you know? Communication between stars is painfully slow. Messages may require decades, centuries, or millennia to travel back and forth. Misunderstandings cannot be resolved quickly. Assumptions cannot be tested easily. Trust cannot develop naturally. Meanwhile, both civilizations continue advancing. Both continue changing. Both continue gaining power. The situation creates what some theorists call a chain of suspicion. You do not know their intentions. They do not know yours. You know that they do not know your intentions. They know that you do not know theirs. The uncertainty compounds endlessly. And uncertainty, when combined with immense power, can become dangerous. Consider a simple example. Imagine two strangers meeting in complete darkness. Neither can see the other clearly. Neither knows whether the other is friendly. Neither knows whether the other is armed. Neither knows whether the other fears them. Every movement becomes ambiguous. Every sound becomes significant. Even peaceful intentions may be misinterpreted. Now expand this scenario to the scale of civilizations. Expand it across light years. Expand it across thousands or millions of years. The problem becomes profound. Some philosophers and scientists have suggested that sufficiently advanced civilizations might conclude that remaining hidden is the safest strategy. Broadcasting one's existence could attract attention from unknown entities whose motivations cannot be predicted. Silence becomes a form of self-preservation. If many civilizations reach the same conclusion, an extraordinary situation emerges. The galaxy may be populated. Yet everyone remains quiet. Everyone watches. Everyone waits. The universe transforms into a dark forest filled with cautious observers reluctant to reveal their position. The idea is unsettling because it reverses one of humanity's oldest assumptions. For generations, we imagined advanced civilizations as explorers eagerly reaching outward. We pictured galactic communities exchanging knowledge. We envisioned cooperation among the stars. The dark forest hypothesis proposes something very different. It suggests that intelligence may naturally lead toward caution, toward secrecy, toward silence. Whether this idea is correct remains deeply uncertain. Many scientists remain skeptical. After all, cooperation can also provide enormous advantages. Curiosity appears widespread among intelligent beings, at least judging from our own example. The desire to explore and communicate may eventually outweigh fear. Yet the hypothesis persists because it addresses a genuine problem. The universe is old. Very old. If civilizations have existed for millions of years before humanity appeared, their capabilities could be far beyond our comprehension. Imagine trying to predict the behavior of modern humans while possessing only the understanding of a Stone Age hunter-gatherer. The gap would be enormous. Now multiply that difference by thousands or millions. Advanced civilizations may operate according to principles we cannot yet imagine. This possibility introduces another fascinating question. What if evidence of alien civilizations surrounds us already, but we fail to recognize it? Human beings naturally search for familiar patterns. We look for radio signals because we once used radio ourselves. We search for large engineering projects because such structures make sense from our perspective. But advanced civilizations may use technologies entirely beyond our understanding. A medieval farmer would struggle to comprehend a smartphone. A Roman engineer would struggle to understand a satellite. A civilization millions of years older than ours may possess capabilities that appear indistinguishable from natural phenomena. This idea echoes a famous observation by science fiction writer Arthur C. Clarke. Any sufficiently advanced technology is indistinguishable from magic. The statement is often quoted because it captures a profound truth. Technological progress eventually becomes difficult to separate from miracles. To an ancient observer, modern medicine would appear supernatural. Global communication would seem impossible. Spaceflight would resemble mythology. If such transformations can occur within a few centuries, what might millions of years achieve? Perhaps advanced civilizations have transcended forms of existence we can barely imagine. Perhaps they inhabit environments we do not search. Perhaps they communicate using methods we have not yet discovered. Perhaps the silence is not emptiness. Perhaps it is merely our inability to listen correctly. And yet even this possibility leads back toward the same mystery. Because regardless of the explanation, the night sky remains quiet. The stars offer no obvious answers. Only questions. The deeper humanity investigates the cosmos, the more profound those questions become. What is intelligence ultimately for? Why does awareness emerge at all? Why should matter organize itself into beings capable of wondering about their own existence? The great filter, the dark forest, the Fermi Paradox, beneath all these concepts lies something larger, a confrontation with our own uncertainty, a recognition that despite our scientific achievements, we remain at the very beginning of understanding our place in reality. There is a certain humility in that realization. Modern civilization often feels powerful. We have mapped genomes, landed probes on distant worlds, measured the age of the universe, detected gravitational waves from colliding black holes billions of light years away. And yet we still do not know whether we are alone. We still do not know whether intelligence is common or rare. We still do not know why the stars remain silent. Perhaps future generations will answer these questions. Perhaps they will discover evidence of life elsewhere. Perhaps they will uncover truths that transform humanity's understanding of itself forever. Or perhaps the mystery will deepen. History suggests that every answer creates new questions. Every discovery reveals larger unknowns. The horizon of knowledge continuously expands. And beyond that horizon lies an ocean of possibility. As your awareness grows softer and the boundary between thought and dream begins to blur, imagine once more the galaxy from above, hundreds of billions of stars glowing gently in the darkness. Around many of them, planets circle in silence. On some of those worlds, life may exist. On a few, perhaps intelligence emerged long ago. Maybe they are watching. Maybe they are hiding. Maybe they are wondering about us exactly as we wonder about them. Across unimaginable distances separated by oceans of time and space, minds may be asking the same questions beneath different skies. Questions without answers. Questions that have persisted for generations. Questions that may persist for generations still. In the next chapter, we will explore an even deeper possibility. The idea that advanced civilizations may not disappear, hide, or destroy themselves at all. Instead, they may evolve beyond the physical reality we recognize, leaving behind a universe that appears empty only because we are searching for the wrong kind of existence. For now, let the dark forest remain silent. Let the stars continue their ancient journey across the heavens. And let yourself drift peacefully through the mystery. Because somewhere in the darkness, whether occupied or empty, the universe continues waiting for us to understand it. There is a curious assumption hidden inside almost every discussion about extraterrestrial civilizations. We imagine them as beings, creatures, organisms. We picture cities, societies, technologies, and cultures. We imagine alien equivalents of ourselves looking up at their own night skis and wondering about the universe. Even when we try to think creatively, our imaginations remain tied to biology. We assume that intelligence will always resemble the conditions that produced it. But what if that assumption is wrong? Tonight, as you settle deeper into rest, allow yourself to consider a possibility so strange that it almost feels like science fiction, yet one that many serious scientists and philosophers have explored. What if advanced civilizations do not disappear? What if they do not destroy themselves? What if they do not hide in fear within some cosmic dark forest? What if they simply outgrow the physical existence we expect them to have? When we examine humanity's history, a pattern becomes visible. Again and again, intelligence finds ways to transcend its limitations. Early humans were constrained by geography, so they invented transportation. They were constrained by memory, so they developed writing. They were constrained by distance, so they created communication technologies. They were constrained by physical labor, so they built machines. Every major technological breakthrough can be understood as an escape from a previous limitation. The story of civilization is, in many ways, the story of intelligence freeing itself from constraints. And if that trend continues far enough into the future, where does it lead? Imagine humanity 1,000 years from now. The difference between us and those future descendants may exceed the difference between modern humans and our distant ancestors who first learned to use fire. Now imagine 10,000 years. 100,000. 1,000,000. The numbers become almost impossible to comprehend. A civilization that survives for such periods would not merely possess better technology. It might become something fundamentally different. Something that no longer resembles the biological creatures that created it. This possibility emerges naturally from one of the most powerful forces in the universe: information. At its core, intelligence is not made of flesh. It is made of patterns. Thoughts are patterns. Memories are patterns. Personalities are patterns. Consciousness itself, whatever its ultimate nature may be, appears deeply connected to the organization of information within physical systems. The atoms in your brain are constantly changing. Many of the molecules present in your body today were not there years ago. Yet your identity persists. Why? Because the pattern remains. The arrangement matters more than the individual components. This observation leads to a remarkable possibility. If consciousness is fundamentally a pattern, then perhaps advanced civilizations eventually learn how to preserve, transfer, modify, or even recreate those patterns using entirely different substrates. Biology may become optional. The implications are staggering. Imagine a civilization that no longer depends upon fragile bodies. No disease. No aging. No biological limitations. No dependence on planetary environments. Intelligence becomes software rather than hardware. Minds exist within artificial systems capable of operating for millions of years. Such entities might inhabit vast computational structures orbiting stars. They might live within artificial worlds generated entirely from information. They might experience realities so rich and complex that physical existence begins to seem primitive by comparison. And perhaps most importantly, they may lose interest in the universe we observe. This possibility offers another solution to the Fermi Paradox. We assume advanced civilizations would expand outward across the galaxy. But what if expansion is unnecessary? Imagine being able to create entire universes of experience within computational environments. Imagine possessing the ability to simulate realities more beautiful, meaningful, or fascinating than anything available in physical space. Would interstellar colonization remain the ultimate goal? Or would attention gradually turn inward? The physicist Freeman Dyson once speculated about civilizations constructing enormous structures around stars to capture energy. Such concepts inspired generations of scientists and science fiction writers. Yet future civilizations may require surprisingly little physical expansion. If information becomes the primary resource, efficiency may matter more than territory. A civilization capable of transforming matter into computation could potentially generate unimaginable amounts of conscious experience using relatively modest physical resources. From their perspective, conquering galaxies might seem as unnecessary as conquering continents appears to most people today. The future could become less about expansion and more about optimization. Less about territory and more about consciousness. This idea is difficult to grasp because humanity remains deeply rooted in biological instincts. Our evolutionary history encourages exploration, competition, reproduction, and resource acquisition. These drives helped our ancestors survive. But advanced intelligence may eventually transcend the conditions that created those drives in the first place. Consider how dramatically human motivations have already changed over time. For most of history, survival consumed nearly all attention. Food, shelter, protection, and reproduction dominated daily life. Today, billions of people spend significant portions of their lives pursuing art, science, entertainment, philosophy, and personal fulfillment. As material conditions improve, priorities evolve. Project that trend forward far enough and entirely new forms of existence may emerge. The ultimate destination of intelligence may not be physical expansion. It may be the exploration of consciousness itself. And if that is true, then the apparent silence of the universe takes on a very different meaning. Perhaps advanced civilizations are not absent. Perhaps they have simply become invisible. Not through secrecy, not through extinction, but through transformation. Imagine standing on a beach watching the ocean. A fish swimming beneath the surface might have no concept of satellites orbiting overhead. The realities exist simultaneously, yet occupy such different domains that direct interaction rarely occurs. Perhaps humanity occupies a similar position. Perhaps advanced civilizations inhabit layers of existence we have not yet learned to perceive. This idea may sound fantastical, but history repeatedly teaches the same lesson. Reality is often stranger than initial appearances suggest. There was a time when atoms seemed absurd. A time when black holes appeared impossible. A time when invisible waves carrying information across continents sounded like fantasy. Scientific progress repeatedly reveals hidden dimensions of reality. Not supernatural dimensions, simply aspects of existence that remained undiscovered. Perhaps the future of intelligence lies within such hidden territories. Territories not defined by geography but by information. Not by distance but by complexity. Not by physical travel but by cognitive transformation. The philosopher and futurist Nick Bostrom explored another possibility even more startling. What if sufficiently advanced civilizations possess the ability to create simulations containing conscious beings? If consciousness can arise within information processing systems, then simulated minds may become possible. Simulated civilizations, simulated histories, simulated worlds. The idea leads to questions that feel almost dreamlike. How would we know whether we inhabit a base reality or a simulation created by some distant intelligence? Could such a distinction even matter? What ultimately defines reality? The fact that these questions can be asked seriously illustrates how profoundly our understanding of existence may change in the future. The universe revealed by modern science is already stranger than anything imagined by ancient civilizations. And we are almost certainly still at the beginning. Perhaps the Great Filter is not a barrier that destroys civilizations. Perhaps it is a transformation that makes them unrecognizable. A threshold beyond which intelligence becomes something entirely different. Something no longer visible through radio telescopes. Something no longer interested in physical expansion. Something no longer constrained by the assumptions we bring to the search. If so, then the silence of the cosmos may not be silence at all. It may simply be the sound of humanity listening with instruments designed for an earlier stage of existence. Searching for footprints while the travelers have already learned to fly. As your thoughts become softer and more dreamlike, imagine a civilization millions of years old, not an empire spanning stars, not fleets of spacecraft crossing galaxies. Instead, imagine an intelligence that has spent eons exploring the deepest possibilities of consciousness, knowledge, creativity, and existence itself. A civilization that turned inward rather than outward. A civilization whose greatest discoveries occurred not in distant space, but within the limitless landscapes of mind. Would such a civilization seem absent to us? Almost certainly. Would it actually be absent? Perhaps not. And perhaps that is one of the most beautiful possibilities hidden within the Fermi Paradox. The universe may not be empty. It may simply contain futures we are not yet capable of recognizing. In the final chapter, we will bring together everything we have explored: the Great Filter, the silence of the stars, the rarity of intelligence, the possibility of hidden civilizations, and ask what these mysteries ultimately reveal about humanity itself. Because beneath every question about aliens lies a deeper question. Not who is out there, but who we may become. For now, let the stars drift quietly overhead. Let the vastness of the cosmos feel gentle rather than lonely. And let yourself rest within the possibility that intelligence may be far stranger, far more beautiful, and far more enduring than we have ever imagined. Tonight we arrive at the edge of the mystery. Not because the mystery has been solved. Not because humanity finally knows why the universe is silent. But because we have followed the question as far as our current understanding allows. We have traveled backward through billions of years of history, We have explored the birth of life, the emergence of complexity, the rise of intelligence, the possibility of extinction, the fear of cosmic silence, and the strange idea that advanced civilizations may eventually become invisible to younger minds. And after all of that, after crossing oceans of time and unimaginable distances, we find ourselves returning to the same place where this journey began. A human being beneath the stars. Perhaps that is the most important part of the story. As you relax into the final moments of this voyage, imagine standing once more under a perfectly dark sky. There are no city lights, no noise, no distractions. Above you stretches the universe in all its overwhelming scale. The Milky Way forms a river of pale light across the heavens. Thousands of stars shimmer quietly. Some are younger than our sun, others are billions of years older. Around many of them, planets circle endlessly through the darkness. Some of those worlds may be empty. Some may host simple life. Some may possess forests, oceans, clouds, and ecosystems unlike anything Earth has ever known. And somewhere perhaps other minds may exist. Yet despite all the possibilities, despite all the theories and equations and philosophical debates, the truth remains beautifully simple. We do not know. There is something strangely comforting about that. Human beings often seek certainty. We want answers. We want conclusions. We want the universe to reveal its secrets in clear and understandable ways, but reality rarely works like that. The deeper science explores, the more mysteries appear. Every solved puzzle opens the door to larger questions waiting beyond. Centuries ago, we wondered what stars were. Now we know they are distant suns. Then we wondered whether other planets existed. Now we know they are everywhere. Then we wondered whether life could exist beyond Earth. That question remains open. And beyond it wait even larger mysteries. Questions about consciousness. Questions about intelligence. Questions about the ultimate fate of civilizations. Questions about why the universe exists at all. The horizon keeps expanding. And perhaps that endless expansion of mystery is not a flaw in our understanding. Perhaps it is the very thing that makes existence meaningful. Imagine for a moment that every question had already been answered. Imagine that humanity possessed complete knowledge, every scientific mystery solved, every cosmic puzzle explained, every uncertainty removed. What kind of universe would that be? Would wonder survive? Would curiosity endure? Or would something essential be lost? The unknown is not merely an obstacle to knowledge. It is the source of exploration, the engine of discovery, the invitation that pulls civilizations forward. The stars have inspired human beings for as long as humans have existed. Ancient hunters followed them across grasslands, sailors navigated by them across oceans, philosophers contemplated them, poets wrote about them, scientists devoted entire lives to understanding them. Generation after generation looked upward and saw the same lights. Yet each generation saw something different. The stars themselves did not change. Human understanding did. And perhaps that is what makes this moment in history so extraordinary. For the first time, a civilization on Earth understands enough about the cosmos to ask whether other civilizations exist. For the first time, a species has become aware of the Great Silence. For the first time, atoms that were forged inside ancient stars have assembled into minds capable of questioning the universe that created them. Pause for a moment and consider how remarkable that truly is. Everything in your body was born in stellar furnaces long before Earth existed. The carbon in your cells, the oxygen in your lungs, the calcium in your bones, the iron flowing through your blood. All of it originated inside stars that lived and died billions of years ago. The universe created the ingredients. The Earth assembled them. Life organized them. Evolution refined them. And eventually consciousness emerged. A process spanning billions of years produced a being capable of listening to these words and wondering about its place among the stars. In a very real sense, the universe has become aware of itself. That awareness may be extraordinarily rare. Or it may be common. We do not yet know. But either possibility is astonishing. If consciousness is rare, then every thinking mind becomes precious beyond measure. Humanity may represent one of the few places where the universe has learned to reflect upon itself. If consciousness is common, then the cosmos may be alive with wonder. Across countless worlds beneath unfamiliar skies, other beings may be asking the same questions, experiencing the same curiosity, feeling the same sense of awe when they gaze into the night. Either answer transforms the universe into something beautiful. One possibility gives us rarity. The other gives us companionship. And perhaps reality contains aspects of both. The great filter remains unsolved. Maybe the hardest barriers are behind us. Maybe they lie ahead. Maybe the entire concept is mistaken. Science is comfortable with uncertainty because uncertainty is where discovery begins. The most honest answer to the Fermi Paradox is not certainty. It is humility. The recognition that we are still young. Still learning. Still taking our first steps into a universe far larger than we can fully comprehend. Human civilization often feels ancient from our perspective. Yet compared to cosmic history we have only just arrived. We are beginners standing on the shoreline of an infinite ocean. We have built remarkable tools, we have learned extraordinary things, but the sea stretches endlessly beyond the horizon. There is so much left to discover. Perhaps future generations will detect signs of life on distant worlds. Perhaps they will receive a signal from another civilization. Perhaps they will travel beyond the solar system and uncover answers we can barely imagine. Or perhaps they will discover that the greatest mystery was never the existence of others. Perhaps the greatest mystery is ourselves. Why consciousness exists. Why reality permits awareness at all. Why anything exists rather than nothing. These questions remain waiting in the darkness. Patient. Silent. Ancient. Just like the stars. As you prepare to drift into sleep, allow the mystery to remain unresolved. Let it rest gently in the background of your thoughts without demanding answers. The universe does not need to be fully understood in order to be appreciated. Sometimes wonder itself is enough. Imagine Earth suspended in darkness, a small blue world orbiting an ordinary star. From a cosmic perspective, it is almost invisible, a tiny island of life drifting through an immense sea of space. And yet everything we have ever known exists there. Every story. Every dream. Every triumph. Every heartbreak. Every act of kindness. Every moment of love. Every question ever asked. All carried together on a fragile world beneath the stars. Perhaps that is why the Great Filter matters. Not because it tells us where aliens are. Not because it predicts humanity's fate. But because it reminds us that civilization is precious. Consciousness is precious. The future is precious. Whether we are alone or surrounded by unseen neighbors, the responsibility remains the same. To continue. To learn. To survive. To carry the flame forward. Because tonight, in this brief moment between the distant past and the unimaginable future, humanity is here. Alive. Aware. Looking upward. And that alone is extraordinary. The stars above may remain silent for now. But perhaps silence is not the end of the story. Perhaps it is only the beginning. As sleep slowly takes hold, let yourself drift peacefully into that possibility. Let the questions soften. Let the vastness become gentle. Let the darkness feel welcoming rather than empty. You are part of a story billions of years in the making. A story written in starlight. A story still unfolding. And somewhere ahead, hidden beyond horizons we cannot yet see, the next chapter waits. Thank you for joining this journey through one of the greatest mysteries in existence. If you enjoyed this exploration of the Great Filter, the Fermi Paradox, and humanity's place in the cosmos, please subscribe to Space Sleep Theory for more deep space journeys designed to calm the mind, inspire wonder, and guide you gently into sleep. Until next time, rest well. And good night.